Today we're going to revisit an old friend, parabolas, and we've spent so much time this year on parabolas, haven't we? Right? You recognize the formula, y equals ax minus h squared plus k. You know the vertex is hk, axis of symmetry, x equals the x coordinate of the vertex, and then that's going to be the new kind of twist on today, this new formula. So first we take a parabola equation, and we can look at this equation and look at those numbers and know that the vertex is 3, 4. So I'm going to go to 3, 4, and then it said that the a here is 3, so I'm going to go kind of up 3 over 1 in each direction, so it's a little off my page there. The axis of symmetry we know is x equals the x coordinate of the vertex, and that we've done tons of times. Here's a new word. A new word is called a focus. A focus is a special point inside the parabola. It's hard to get it exactly right, so I do it with that little star. And we've got a formula for finding it, and it's 1 over 4a is the distance from the vertex to the focus. So in this example, the a is 3. So 1/12 is my distance from the vertex to the focus. The focus is always inside the parabola, so I was at the ordered pair 3, 4, and I'm going to go up 1/12. So what ordered pair do I land on? Right, 3, 4, and 1/12. So again, you can't really graph that, we just put that star. The directrix is a line, so if I go back and like maybe draw in, here was my axis of symmetry, right? The directrix is a special line perpendicular to the axis of symmetry here. And it's the same distance. It's down 1/12 from the point 3, 4. So that would be like, what, 3 and 11/12, and it's a horizontal line, so it's a y equals line. So we have two special points, two special lines. The vertex is a point, the focus is a point, and then the axis of symmetry is a line, and the directrix is a line. One's horizontal, one's vertical. So we try it again, right? So here's another one. Y equals 1/4, x minus 2 squared minus negative 3. Do you agree that the vertex is 2, negative 3, and the axis of symmetry is x equals 2? And this one's a little wider, so up 1 over 4. Wait, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Right? So here we have our nice wide thing. Now we've got our new spot, our new part, which is 1 over 4a is the distance from the vertex to the focus. So this is going to be actually a really great a. Usually fractions make things worse, but here it's going to make it easier. What's 4 times 1/4? 1. That means the focus isn't 1, but the distance from the vertex to the focus is 1. So if I was at the ordered pair 2, negative 3, and I go up 1, what ordered pair am I on? Right, 2, negative 2. And then that's that same distance down, so if I go down from 2, negative 3 and make a horizontal line, I always forget to draw on the axis of symmetry, and make a horizontal line, that horizontal line is at y equals negative 4. And that's it. So let's try another one here. What would the vertex be in number 2? Right, 3, 1. Right 3, up 1. And that negative is going to make it upside down, just kind of normal. Here, I won't forget this time, axis of symmetry, drawing it in. So x equals 3. Then I have focus and directrix. The focus is 1 over 4a. The a is negative 1. So this is, negative 1/4 is the distance from the vertex to the focus. So the negative reminds me that I'm going down. The focus is always inside the parabola. I can't really graph that correctly. I just do the little star. If I go down 1/4 from 3, 1, I'm at 3, 3/4. Then I have to go up 1/4. So if I go up 1/4 from 3, 1, I'm at the horizontal line y equals 1 1/4. And I find mixed numbers are the way to go. We know it's got to get a little harder sometimes, so here it is in number 3. What's different about number 3? It's not in the form I like. Well, good thing I spent a whole chapter learning how to change the form of a quadratic equation. Remember that? Factor out the leading coefficient from the first two terms. Then we're going to, complete the square. Half the middle term squared is 4, which is really adding an 8. But the y likes to be alone. So my equation is y equals 2x plus 2 squared minus 5. So I first have to change the form. Once I change the form, I can get my vertex, -2, -5. This is a of 2, so it's a little tighter. My axis of symmetry is going to be x equals -2. Then for the focus and the directrix, I'm going to use 1 over 4a. So 1 over 4a here, the a was 2, so it's going to be 1 over 4/2, or 1/8. So I'm going to go up an eighth from the ordered pair, -2, -5. It helps me to write that ordered pair. So I'm going to go up an eighth from that, -2, -4, and 7/8. And then the directrix here is going to be y equals -5 and 1/8. So you got to be kind of good at fractions, not going to lie. Last question. So the last one reverses it. Instead of giving you what I call the equation and you finding the stuff, now it's giving me stuff and I find the equation. So it says the focus is 3, 5. I always do kind of a star for my focus. The directrix is y equals 1. Well, the main thing that I have to find to make a parabola is the vertex, right? So I'm noticing that point is 3, 5. That point on the directrix is 3, 1. Do you know what the vertex would be? Right, the vertex is going to be 3, 3. The vertex is right in the middle there. So if the vertex is 3, 3, I have x minus 3 squared plus 3, right? And then it's something like this. But I don't really know the a yet, so I probably shouldn't have drawn it. I don't know how wide or narrow it is. How do I figure that out? What's my formula? 1 over 4a is the distance from the vertex to the focus. What's the distance from 3, 3 to 3, 5? Right, it's 2. And if I cross multiply, I get 1/8. So I'm going to plug that in and get a final answer, 1/8 x minus 3 squared plus 3. So I actually graphed it prematurely. It would have been much wider there. So we'll get rid of this one. It would have been much wider. So yeah, there we have it. Parabolas. Y equals.